Hey everybody, welcome back. We're going to do section 1.3, dealing with quantitative data. This is the last section out of our chapter 1 out of our book. It's halfway through what College Board tells us is Unit 1, and all the one variable unit, or all the one variable data unit. I can speak. And so I want to walk you through this. It's going to seem really familiar. Don't go, don't let your brain go on vacation, because there's some really detailed stuff that we're going to go probably deeper than you may have done before on this topic, and I don't want you to miss that. Okay. What we'd end up doing is that when you go, oh, and before I forget, link down below to the worksheet packet if you want that. It's based off the ones off of StatsMedic. And then my class, you can obviously get that from Classroom. Obviously, if you like what you're seeing, hit subscribe. Always be up to date with the most recent videos. And you probably should hit what's the other one? Like and subscribe, or like, subscribe, and hit the little bell. Anyway, as I'm forgetting the name of the Australian group who always, it doesn't matter. So people come in, they record their height, they put it on the board. So we make a dot plot of that. A couple of things, and I'll get to these colors here in a second. We make the dot plots of everybody's height. When we do that, we have this discussion the first number of times we do dot plots, is that you got to make sure that all the ones are at the same height. If there's two dots at a particular value, they're at the same height. The threes are at the same height. The fours are at the same height. Because otherwise, sometimes people will make different sizes, different values, different heights, and it just gets really hard to kind of really use it usefully. So the first thing that you're asked to do here is find the median. And you may remember from probably middle school, for sure, in our case, algebra, of going back and blocking off the numbers to find the number in the middle. If it's odd, it's going to be the number that's left over if there's only one number. Okay, so kind of blocking off each side. If it's even, you're going to average the two numbers in the middle. So in our case here, it turns out to be, you're going to block off, boom, 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 and it's this number right here. There's 11 pieces of data, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pieces of data here. So this first 68 is your median. And then I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pieces of data back there. Okay, so that's important to know. Now, why is that important to know? Is because when you're asked to find Q1 and Q3, remember that's quartile 1 and quartile 3, you're going to find the medians basically of the top and the bottom. Q1 is the median of the lower half. So I'm going to do those numbers here. And then it's also the median of the upper half. So I'm going to include that first 68 and everything else up over here. So if the number is part of your data set, if it's an odd number of values, do not use the median as part of either half. I usually say, think of it, it's the balancing point. If that's your balancing point, you can't really, you're not in either half, you're right in the middle, okay? If you end up calculating out the middle like we do here, then that number is not in the middle, and so those other numbers can go ahead and be included. So when you do this, we have 23 here. Our median was 68. So again, if we're looking down here, we're going to look for our bottom half. So these two, these two, these two, these two, these two, that one. Okay, so 65 is your middle on that one. So that's going to be Q1. That's going to be my median. So that's going to be 65. We're going to do the same thing on the top. Remember this first number here. The second one here is actually part of the top 11. So I'm going to go here, 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 and okay, look, it's 69. Who would have thought? There's a giant spike there. So you get 69 there. And then obviously the minimum is the smallest number and the maximum is the largest number. I know, shocking, right? Okay, so then what we're going to do is we're going to make a box plot. Now I want you to leave enough room here. Sorry. You need to leave enough room here that we're going to potentially have to make a second one. Okay, so a couple of things here. The way that we generally make box plots is we're going to make a line here at 68. That's your middle. We're going to make a line here at 65, a line here at 69, and we're going to connect those. Sometimes these are called box and whisker plots. 61 is down here, and we generally leave it like that. If you make the line there, I don't believe it's that big of a deal, but usually you'll see it like this in the AP Stats books. Get that. In fact, if you're not sure, take a look. Hey, oh, that one actually has them like that, so we're fine. All right. Ta-da! We've got a box plot. Now, interquartile range, IQR, is defined as Q3 minus Q1. Now, remember when we talked about the range, we said the range is a number, not the space between. We're not saying it goes from this number to this number. It has to be a number. So the same thing here. The IQR is found, if you remember, Q3 minus Q1. So in that case, 69 minus 65. So I have an IQR of 4. Remember, that is the length of the box. Now, remember, since these are quartiles, 25% of my data is falling between 61 and 65, 25% of my data is falling between 65 and 68, 25% of my data falls in between 68 and 69, and 25% of my data runs from, I shouldn't say falls between, runs from 69 to 76. Okay, so it's all broken down like that. Now, outliers. This is going to be the part that you may not know. Outlier is the data value that's either way too small or way too big, using the rules below. Okay, great. Apparently mine didn't print out so nicely on my home printer. We'll fix that. Are there any outliers? Show your work. So way too small, the way that you find out way too small, it's going to be Q1 minus 1/2, actually 1.5, sorry, of the IQR. And for way too big, it's going to be Q3 plus 1/2 of your IQR. So what you end up doing here is that you're going to say, okay, my lower quartile is 65 minus 4 times, 1.5 times. I need to get some liquid paper. Just got the numbers switched. So that's going to be what, 6? So that means that my lower number is going to be 59. Hey, that works. Now notice here, 59 down here, I'm within my, that's not an outlier. So we're okay there. On the top, I'm going to go 69 plus 1.5 times 4. And that's going to be another 6. So that's going to give me 75. Now notice here, what ends up happening is that it does give us an outlier. Because this is one boundary here, this is the other boundary down here. When you have an outlier, you're going to redraw it. You're going to redraw the picture as you have. So my number here, this is going to be revised. That's on the screen. Good. Okay. So I've got 61 as my minimum. 65 is still Q1. Still have 68 and 69 as my upper quartile. But now I'm going to put 73 is going to be the upper number there. And then what I'm going to do is I'm going to put a star at 76. Okay? Use a star for outliers. Because what that's doing, what's it saying is that that number is way off and it's going to skew all of our data. So if we were using the mean would drift towards that. We've already kind of talked through that. Now, one other thing, there's always the question of why is a 1.5 IQR? To be perfectly honest, and I've looked this up in a couple of books, because 1 IQR is not enough. We get too many outliers. If we go out to 2 IQR, we don't get enough outliers. And so 1.5 seemed to be a happy medium. All right, so that is going to end this video. Down below is going to be a link to the second part where we go through the important ideas box that for your notebooks, and then we'll have you going through your check your understanding. So I'll see you in a minute. Oops.